Here's something weird about sound. It's World War I, and artillery fire rings out across a battlefield. Far, far away, the blasts are deafening, breaking windows. But nearby, the air is quiet. How? This happens with nuclear weapons, meteors, even the loudest sound in human history. It's called an acoustic shadow zone. Let's figure out how it works. First, we have to understand that the speed of sound is not the same 331 meters per second everywhere. It moves faster in hotter regions and slower in colder regions. When sound moves from one of these regions to another, it bends or refracts, just like this laser going through a lens. See? Think of sound like a shopping cart. If it's between cold air and warm air, the colder side is going slower. And on a shopping cart, if one of the wheels is going slower than the other, it'll turn in that direction. Right? Or you can just think of it as lazy, since it'll always bend towards the place it can move the slowest. During the daytime, the air is hot near the sun-warmed ground and colder as you go up. But because it can move slower up there, daytime sounds tend to bend upwards. And for the very loud sounds we're talking about, they go very far upward. But somehow it comes back down. Let's talk about the layers this sound is going through. We exist in the troposphere from 0 to 12 kilometers. As we go up in the troposphere, the air keeps getting colder and our sound just keeps climbing. Then we hit the stratosphere, where ozone lives. And ozone absorbs UV radiation from the sun and heats up. And the higher in the stratosphere, the higher the temperature. That means that as the temp rises, the air wants to bend back downwards towards the colder troposphere. Now, for an enormous explosion like Krakatoa, the sound gets ejected even further up, all the way to the thermosphere, where the temperatures can reach 2000 Celsius. Then the same mechanism occurs and it comes down. It's not reflecting like this mirror, but refracting like our lens earlier, curving slowly down. So when our wave finally does come back down to Earth, it's miles and miles away from where the original sound happened. And that's where it's loud. But wind plays a big role too. This one's easy. If a sound is traveling downwind, it bends down. If it's traveling upwind, it bends up. And because our atmosphere is so turbulent and unpredictable, we can't say where exactly the sound will come down. We know what's happening, we're not sure where it's gonna happen. That's why some places at the same distance, but in different locations, will get more or less sound depending on the conditions of the atmosphere. The furious sounds of Krakatoa's eruption were literally deafening 100 miles away. Some people nearer barely heard it. The horrific artillery barrages of World War I broke windows far, far away. Close by villages were often peaceful. Acoustic shadow zones. Insane. We have a lot more to explore for how sound interacts with the atmosphere. Wait till you hear about gravity waves. But for now, thanks for watching. Have a good one. I need some water. I don't know why I did this on such a hot day. Hope you liked it.